How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a flywheel off a C32 V12 Cat engine out of a 777 dump truck, and we need to make a drive plate for it to go from the flywheel to an engine dyno so our customer can test run the engine before it goes back in the truck. So this is an urgent rush job. Our customer needs this back today, so we're going to get straight into it. And the first thing we're going to do is get the flywheel in the hot wash to remove all the grease and tectile off it. So while that's getting washed, we're going to cut the piece of plate we need. And what we're using is a piece of 16mm 350 grade plate. This was meant for another job, but we don't have time to wait for a piece of material to be cut from our supplier, so we're just going to have to use this and get it replaced. First thing we need to do is mark the center and hit it with the center punch, and then we're going to scribe a circle at 480mm diameter. We do need to finish machine this to size, so I'm going to give myself about 10mm to clean up. Now with that cut out, we're going to get it set up in the lathe. I am going to face it to clean it up, and that will also give a machine surface for the drive coupling to bolt onto. Next thing we're going to do is standard drill it and drill it to a 15.5mm hole. Now that we've drilled it, I'm going to ream it to 5/8 to suit the pin on our drive coupling. So this is a drive coupling, it's also called an adapter plate. This face here bolts onto the input shaft for the dyno, and the other face bolts onto the drive plate that goes in the flywheel. And this adapter plate I made for our customer a fair few years ago, and we're just going to test fit the pin in the drive plate. So I'm happy with how that fits. Now we're going to get this out of the lathe and get it set up in the mill. So because we're going to be drilling quite a few holes, one thing I need to keep in mind is the placement of my 1, 2, 3 blocks and my clamps, so I don't drill holes through them. Now we've got that set up, we're going to drill the 8 holes that bolt the drive plate onto the coupling. We're just going to double check the measurement of the bolt centers. It should be 5.5 inches, which it is, and if we convert that from bananas to English, it's 139.7 mil. And to drill the bolt holes, we're going to be using the PCD function on our digital readout. It's very easy to use. First thing we put in is the radius, which is half of the diameter. There is the option for a start and an end angle. We don't need that. And the last thing is a number of bolt holes, which is 8. And that's giving us the location for the first hole. So we just move the table till it hits 0. Whoa. So that's our first set of holes drilled. It's really easy with that PCD function. Now with those holes drilled, we're going to move back to center so we can get set up to drill the next holes. And these holes are going to be what's used to mount the drive plate into the flywheel. So we're going to use our PCD function again, but we are going to be right on the limit on the y-axis of being able to reach all of the holes. The hole centers on this are 430 mil, so we're going to input 215 on the radius, and we have 6 holes to drill.
Are you serious? Oh, has it made it? That was close.
Righto guys, so that's those holes drilled. We had just enough travel left on our y-axis to get those completed. And now I'm just going to take it over to the bench and chamfer those holes by hand.
Or do they not need it?
They need it.
Okay.
Now that we've got that done, we need to finish machining the OD in the lathe, and to do that I'm going to bolt on the drive coupling, and that'll give us something to grab onto with our chuck.
Ew.
Where's your piggy? Go piggy. Go piggy. What's that? Look, wait.
Go.
What do you got?
Drop it. Homie, listen.
Tug of Wars is the game.
Drop it.
You're gonna break it. Righto, you win.
Alright, come on. Bring your pig. Come on, inside. Come on.
So at the moment our plate is measuring at a rough 477 mil, and we need to machine it down to 466.3 to suit the inside of the flywheel. Because it's a flame cut edge, we need to take it very steady so we don't break inserts, so I'm just going to lower my feed rate. So we've machined through the majority of that interrupted cut, and it's measuring up at 475mm. So we're just going to keep machining till we get it closer to that finished size.
Ooh, that's nasty.
So I've got the OD machined to size. Now I'm just going to machine a little bit of this face, which will give us a machined surface to sit on this face in the flywheel. So I'm not really happy with that surface finish, so I'm just going to speed it up and take another 0.1 of a mil. So that looks a lot better. The last thing we need to do to this is chamfer those edges. Righto guys, so that's our drive plate completed, but the job's not finished just yet. We still need to drill and tap some holes in the flywheel so the plate can be bolted into it. But I know we're going to have issues with this in the mill because this is 110mm bigger in diameter than our drive plate. So what we're going to have to do is drill the holes in 2 setups. Now that we've found center, we're going to use our PCD function and drill the first 4 holes. So these are going to be blind holes and we need to drill them about 30mm deep. Now we're ready to tap it and I'm using a 5/8 UNC spiral tap. Unfortunately, because this was a rush job, I wasn't able to order in a new tap for this. The tap I'm using, it is quite old and it is a little bit blunt, so hopefully we don't break it. Now we've got those 4 holes drilled, we are going to have to change the setup because if I move to hole 5, the back of the flywheel is going to contact the column. So this would have been a perfect job to do with the Zaya with the drilling attachment, but we already have another job set up in that, and that just would have been too time consuming to change it. So what I'm going to do is move the ram out about 55mm, refine center, and then we can drill holes 5 and 6. Heaps. Righto guys, so we've successfully drilled all the holes in the flywheel. Now we're going to put this thing together. So we've got that bolted together, everything fits exactly how we want it to, it's nice and neat. Now we're going to get it back to our customer because they're in a big rush for it and they need to test run their engine. That's it for this job, thanks for watching. How you going, guys? How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a flywheel off a C3012 V12 Cat. What?
You said C3012.
Give me a second. Right. Amazing. What was after that? So we are finished machining this to size so it fits inside the flywheel. So we've given out.
Stop. There's too many so's.
There is the option for a start and an end angle. There's also an option of a start and end angle. We don't need that. And the last thing is, it's very easy to use. We just put. It's very easy to use. First thing we. Oh fuck me. Right. It's not easy to talk about. It's easy to do. So that went. You hear a train? Right.
Sorry.
Because it's a flame cut. So I've got that machine to size. Righto, guys. But we already have a job. So this would have been a perfect. And it just would have been. And it would. And it just would have been more to. And it. And it just would have been more to. Stop. Reset. And it would have been more time consuming to change that. So we're just gonna. What's the end bit? And it would have been more time. And it would have been more time. Stop laughing, man. And it would have been. Oh my god. And it. Just stop.
I'm losing it.
I'll get it.
Oh my god.
What? I'll get it. Stop getting angry. There's no point getting angry.
I'm not.
I'm not angry.
I'm not getting angry. I'm going to get even.
Hey, what you got? Hey, give me that. Alright, good boy, come on.